All right. Hello, everyone, and welcome back. This is Sentient Cloud. So it's a little bit later today, has some stuff going on, but we're here now. I might extend the time that I stop to 11:15, but we'll have to wait and see. So, with all that said, let's get back to working on this lexer. So, I did a little bit of work yesterday after the stream was over, trying to figure out how to fix that issue. I think I've succeeded. So, I'll show you guys the code here in a minute, but basically, it just attempts to make sure that whenever I run into a new line character, regardless of what state it's in, it will automatically increment the line and reset the column. So, for example, if I look for this value2 line here, so the way you do that, so we could go to syntax.ys, and it goes at 172. So if I try to move to 172, it is technically going to be a little bit different. It's going to be one less than it should be. That's just because of the indexing, right? The line numbers here are base 1, and the numbers there are base 0, but that's pretty easily fixed. So, with all that said, I think that's everything. All the stuff that I need to do for that. There are a couple other things, like some extra operators that I could put in, but they're not really necessary. For example, bit shifting operators. They're helpful sometimes, but you don't actually need them. So if you didn't know, you can actually, I think you can copy their behavior directly by just using multiplication by powers of 2. And I think that actually most compilers will actually optimize that, just because, like, if you are multiplying by power of 2, then it will just do that, assuming that it can. So anyway, all right. So, with all that said, let's start. See, I guess the parser is probably the next thing to work on. So let's go to parser.c, and this is where things are going to get kind of interesting. So first off, going to fix the naming scheme there. And we'll just get rid of all this, because this is no longer necessary. So. Okay. I guess we're going to go to parser. Nope, wrong place. Hold on. Parser.h. So there's some stuff in here that I'm going to need to do. First off, fix this. All right, so we've got the AST there, but I'm going to need to put in a bunch of other stuff. Okay, so let's start with, I guess, variable declaration. So actually, there's going to be a bunch of this. This is where, actually, I should probably put this into its own separate file, because it's sort of similar to tokens. Having all of the AST and the nodes and all that defined here is just going to make this file really, really kind of big and bulky. I don't know. I mean, it's not really going to be a huge deal to do it that way, so I guess we'll just keep going with that. Okay. Okay. So first we'll name that to AST. I'm going to, instead of passing a file, I'm going to just pass code. I should probably also do length. I might actually take some time. Let's see, do I need to do that? I'm not sure if I need to take the time to go ahead and define a string type. That might be helpful. Yeah, that might be quite helpful. I don't know. I'll have to think about that. Anyway, I am going to include length of the string, so that's something you can define. And all right, let's see. So first things first, I'm going to be treating everything as if it's an expression. Struct ID expression. Jeez, can't type today. And that's going to, actually I'll shorten that. There's no need to make that entire thing. And this expression, it, excuse me, enum expression type. So this is going to contain all the various possible types, which I'll define here, a couple of them in a minute. Okay, what else? We need the data, and that's going to be def, I think union ID expression data. So this is going to have a type. And data. And I do want to have the information around like every part of this. So like, for example, the kind of location within the file for all of this. That's something that I do want. So, but for now, we'll just look at this. So as far as the data is concerned, we need integer, unsigned integer data. So we'll say, let's call that uint. I think that would be, no, because those are both. Let's see, I want to make sure I pick something that's not going to collide. Let's real quick. Size, I guess we'll just call it usize. No, that won't work. Never mind. I guess we'll go something like this. And then isize will be sint, something like that. F64 will be float. Let's call it F. Sure, why not? Okay. That's going to be string. And then I think the last one we need to worry about is void. And this will just be, I guess we'll just call it pointer. And I'm also going to include, let's see, let's call them chars or C. I'll shorten these all like this. So this is going to be for individual characters, and then if we discover that we have a string that is greater than 7 characters, then it's going to have to go in here. Right. So this is actually somewhat similar to how C++ does things for their strings. The string is implemented such that if it's a really short string, then it's something like, I think 27 characters is the max for that. It'll use this kind of implementation and just work with it like this. And the idea is just to make it so that if you have a really short string, it's not going to take up much more space. So anyway, back to this. So yeah, this will be S, or I guess we'll just call it I. So there we go. And I suppose since I'm using 64 there, we'll just go with I64 and U64 as well. There. Okay. So that's all the possible types of data. And actually, I might... no, I can't make it store expressions. The reason for that is there's going to be different structures that store expressions as a part of them. So like, for example, just to kind of show you guys what that would look like, let's do struct yd funcdef. So this would be, this would have as a part of its definition a list of expressions that it would go through when you execute the function. I should when you compile this actually. Until I put in an interpreter, it's not going to execute this stuff within there. I don't know if that made sense. It doesn't matter. I'm getting sidetracked. Anyway, okay, so this is going to be expressions and number of expressions, and this is just going to be like a long list of expressions. So that's all that needs to do. Okay. Okay, so let's go ahead and define some of the types here. Some of them you've already seen. So the first one here I'm going to say is error type. And actually, I should make sure to put down ET. So there, equals 0. And so all this is my idea here is that the when it goes through, it's going to move, and it's going to go through, and then when it encounters an error, so for example, let's say we've got a constant, x that is a, let me think here, what would be an example? Let's say that it has no value. So let's say that we say that it's, a U size for whatever reason, but we don't give it a value, right? This would not be valid. This would be something that's, I don't know if this is something where I need to have this happen at parse time, but I definitely I'm partial to it being discovered at parse time, because there's no reason to go and evaluate this if I can tell right away that this is not going to work, right? Now that's not possible if, for example, I were to do something like this. won't say it's not possible. It's just not very feasible for this part because I'm not evaluating. Because so basically, it would go through. It's like, oh, okay, here's const. So it's a constant declaration or definition in this case. Oh, it's X. That's an identifier, so that's fine. Colon, and then the type. So all that's valid so far. And then assignment to this, right? All this is valid, right? The problem, at first glance, this is valid. But it would take this telling that this is actually an error because you can't have a usize with this. I think that should be something that's handled at during evaluation rather than during rather than during parsing. But I think during parsing this can be evaluated and said to be false. And maybe a better example would be something like const usize. Maybe it would be better to not worry about. Oh, oops. Maybe it's too complicated to say that this is false during parsing, but this is definitely false during parsing, right? Const and then usize is very much a keyword, so you can't say, oh, that's a valid parsable thing. I just realized I'm not looking at the actual chat. Okay, cool. Anyway, so yeah, that's this. I suppose we could say that this is technically valid for during parse time, but then during evaluation time, it's going to be like, oh, okay, that's not valid anymore. You're not allowed to just have a constant that's got no value, right? I think that makes some sense. And so this is definitely not possible. That's what this error type would handle. And so you would have this error, and it's not going to consume more tokens than it should. So I'll have to figure out how to make sure it does that. Otherwise, there's going to be problems. But yeah, that's going to catch all the errors, hopefully, including lexing errors. The lexer is not going to be something that anything external to this program is ever really going to interact with directly. That's something that only the parser is talking to. I just put it in the CLI just to test it. So, okay. Let's go through and do a couple more. YD, ET. And what else? Let's do var def. Or var dec, I guess. I don't know. Hello. How's it going? I guess declaration makes more sense in this case, since that's definition is something that's handled through the assignment operator. So also we'll want to include const dec. There we go. So I haven't fully decided on that, but my instinct right now is to kind of use the same strategy that I've been using for the lexer, which if you've been watching, I'll go ahead and just go over there to show what I'm doing. We'll go here. So I am using labels and basically just bouncing around this function to wherever I need to go and using switch statements to parse through the code file. And then, so my plan is to kind of do something similar, except rather than looking through the characters, I would be looking through the types of the tokens. So that's kind of what I'm planning, but see if that actually pans out. Okay, let's see. So what else, I guess? I don't think there's going to be a situation where I'm planning to... Should I allow for functions that don't have a value? Operator precedence. I am not totally certain, but I think it would be so. Basically, what I'm thinking here is so I don't know if you know much about stuff like tail call optimization and some of that kind of stuff, but the basic premise is normally when you call a function, it will pause essentially execution where it is and create a new stack frame and then start working within that stack frame. This is where the whole concept of Stack Overflow comes from because, if you start a bunch of functions, especially if you're doing a lot of recursive function calls, you will end up growing the stack to the point where you go too far and you can no longer, there's no more memory. You can't do things. And so tail call optimization is basically allowing you to, if you have two functions that have like the same parameters, or same parameters, and then you call one function at the end of another function, that you can basically move onto that next function without increasing the stack frame. You just use the stack frame you already have. So that's tail call optimization. Apparently, LuaJIT, the Lua just-in-time compiler, uses this as a way to speed up execution because then you don't need to grow the stack, you don't need to remove the stack. When you're done with that function, it's much faster that way. In practice, the difference between calling a function that doesn't grow the stack and just using a jump or a goto is, as far as I can tell, pretty minimal. And so, in principle, like if you're using a recursive descent to parse what you're doing, and you utilize tail call optimization as would be the ideal circumstance, then the difference between that and using goto should be pretty minimal. And I just found that using the goto method just kind of made more sense to my brain rather than relying on tail call optimization, which is not a consistent thing that you can always rely on. Right? You can always rely on goto working the way it's supposed to in C. You can't always rely on the fact that the function that you are defining and using will be optimized to use tail call optimization. So that was kind of my reasoning there. And so if things work out the way that I expect them to, then the precedence will be handled basically in the same way that it would have been handled otherwise. You go to wherever you're parsing through that section of the code, and then if you discover, oh, there's a plus sign here, then you would go to a different segment than if you discover there's a multiplication sign. So I'm pretty sure it'll work. We'll have to wait and see, but that's kind of my inclination there. So anyway, I forgot semicolon. In fact, actually, I'm going to I think we'll call that declaration there. Yeah, okay, we'll do it with that for now. All right, I'm just going to go ahead and do a couple here that are a little bit easier to kind of work out and sort of are more relevant to what you were describing there. And then T. And actually, those are primary expressions. I'll just shorten that. Okay. So actually, I can't do it. I can't call it a primary expression like that. Let's see. Need to do. Shorten those. All right. Let's see. Is there anything else? I don't think I need to include comments there. I guess I kind of do, maybe. We'll worry about those later. They're not as important. Okay, let's get started doing some parsing. Because I think I've got everything I need there. So, actually, before I do that, hold on. I need to go def construct. And we'll also include unary expressions, which would be things like, minus signs and whatnot. Or negations, I guess, not minus signs in general. Okay. So... Alright. Let's go to parser.c. So id parse. What did I call it in the lexer? Start. Oh, that's fine. Let's call it start. Okay. So part of it is because I wanted to do it this way, because I've done some work with recursive descent parsing, but part of it is speed, because recursive descent parsing is slower than doing it this way, but also the cost to do it this way is actually not as high as you might think. So just to give an example first, let me just go ahead and put that down. So you can think of each label as its own function. And so what ends up happening is, like, I call this function here, it goes and does some setup stuff here. This is, not necessarily required, this part here, but that's just something I have set up. And so, you call this function, and then it would call the parse start function, for example. And then you you go and you discover, oh, there's an integer there. There's an integer token. And so, oh, okay, that means you need to call the parse integer function, right? I'm sort of describing this in terms of recursive descent parsing, but in practical terms, you don't, like, a function call is basically an operation where the program puts all of the variables on the stack, all the stuff that it's currently working on, it puts it on the stack, and then it basically initializes the stack frame for the new function, and then does a goto, or a jump, to that function. It's an unconditional jump. So it goes to where that function is defined, and it says, okay, so you need to do this operation, this one, this one, this one. And then once the function is done, normally you would just return, which is another unconditional jump, back to whatever function you're working from. So you can define a function call effectively within the terms of using goto. And in this case, that means that you don't need to initialize the stack frame, because goto does nothing to do with the stack frame. You don't need to, for example, let's say you've got something like this. Let me just go ahead. Excuse me. Let's say you've got some function, and then I'm not going to name it anything, but you've got if this, then return, versus, or else, and actually, if this return true, else return false, right? What's happening is, under the hood, there's a conditional jump right here with the if statement, so I'll just go ahead and define it here. So conditional jump, if I think technically speaking, the way that it checks is if the zero flag is set, but that's not really relevant. Basically, it would look something like this if I do it in assembly. It would be something like GEQ, I think, is how it's done. And then whatever register you're working from, that's not really relevant, but it's going to jump to where this operation occurs. Otherwise, it jumps to wherever this operation occurs. All right, I'm kind of glossing over it a little bit, but essentially, what I could do instead of doing a jump to wherever this operation occurs and then another jump is, in the case of what I'm doing here, I'm basically able to reduce the number of jumps. I'm also not technically performing a conditional jump because in a lot of cases, this stuff can be optimized so that, like if you're using a switch will often get optimized so that it's using what's called a lookup table or a jump table. So it will have like a list of possible values that are put into an array, and that array tells the jump instruction where to jump. And so looking up an array is constant time. It's very fast. It's not like a decision that's being made per se. It's something that's it's mathematical. It's not decision. It's not decision making, strictly speaking, even though it is making a decision. So it's slightly different than if statements, but it doesn't need to check, for example, any of the CPU flags, which is what an if statement will do typically. So that's, I don't know if that necessarily made sense, but essentially the reason is because I want to do it this way, because I think it'll be faster, and because it sort of makes as much sense to me to do it this way as it does to do it the other way. Because a jump is very similar to a function call. You just don't get the benefit of stack initialization, like if initializing a new stack frame. But if I don't need a new stack frame, then there's no reason to do that. It's actually, it's reducing performance for no clear benefit. So that's kind of my thinking there. Anyway, all right. So find a switch here, and this is going to be fairly limited for the moment. But like as an example, let's see. So let's say, and actually I'll define this. I don't need to define the parser that way. Let's do yd token. Token. Actually, no, I can't do it that way. Hold on. Lexer. And I don't remember exactly how the lexer is defined, so let me just go make sure I've got that correct. It's not defined there. Is that defined token.h? It is. Okay. Okay, so token type. Oh no, that's the parser. Oh, that's weird. Hold on. Okay, so it's just given code. Never mind. That's just, I don't need any of that stuff. Okay, cool. So we need token, and then the code. And we've got the code from the argument here. Let's code. Oh, and the length. Don't forget that. Okay. All right. And actually, now that I think about it, it's not defined in terms of length. Okay. It may, but it may not. So the part of the reason that I said this is, one, that tail call optimization, which is essentially what I've been kind of describing is not a consistent thing. You can't necessarily rely on it happening. It's not defined in the standard as this will happen if X, Y, and Z are there. It's something that you can sometimes rely on, but there could be something that you did that makes it so that it's not going to happen. And it might be something you did accidentally, right? So maybe you didn't format things the way that the compiler expects, and so it's like, oh, sorry, not format. Format's the wrong word. Like you didn't lay things out in the way that the compiler expects in order to support that optimization, so it just doesn't do it. Whereas what I'm describing me doing, one, it's guaranteed to happen. The behavior of goto is very well defined in C. Two, it's actually it's not significantly more difficult, and it actually saves me some typing. Because, for example, if I were to do a recursive descent parser, that would look something like this. So I've got this parse call here, and then I would have, yd parse primary, and whoops, something like that. You'd have it return result or whatever that, we'll just call it void for now. We'll just say it returns void. Then you go and you pass all of your arguments. Let's go call it that, and then you define your function, and then you have to declare it up here because you just got to do that. And then you have to call that, and so then you type all that out, you call it, and you got to define all the arguments. But if you don't need to change the arguments, then typing all that out is a waste of time. If you don't want a new stack frame, then defining a function is kind of a waste of time. And it ends up, as far as I can tell, it ends up kind of being a bit of a waste of time in this context. It's a nice shorthand, and for functional languages, this stuff is done a lot more consistently. Like tail call optimization happens a lot more for functional languages because they kind of rely on it to avoid overflowing the stack. But for C, which is not a functional language, you can't necessarily rely on it, and the fact that it has goto already makes it sort of irrelevant. You can just use goto, and it works just fine. And the only... I don't think it's actually going to end up optimizing it better. It would be roughly the same because tail call optimization it's basically the same thing as this in practical terms. So anyway, okay. Let's see. Yd tt. And then, I guess, oh, and that shouldn't be code. That should be token type. Done. Token type. And then we get this by doing I have. I've used recursive descent parsing before. I haven't tested it in this case, but I've definitely used it before. It works fine. It does its job. It's pretty well defined, but yeah. I haven't tried anything other than recursive descent parsing before. This is my first foray into trying to use gotos directly, and it kind of makes sense to me to do it this way. And honestly, I haven't really used goto much previously before just because it's not something that's encouraged, to be sure. But, okay, I need, what's it, lexer goto.h. There. Okay. ATT, and then I think it's, what is it? That. Just list a couple of the really basic things, and in fact, let's just go to here. Yeah, so I'll just copy all these. Actually, no, I can't. Never mind. Can't copy them all at once. One of the limitations of this editor that I discovered, and I haven't figured out how to solve it yet, so I've just kind of been having to work around it, is that copying off the screen seems to cause it to break. Like I said, not sure why that is, but I'm not going to tempt fate. Oh, jeez. There we go. All right. Just copy all that in. And let's see, I don't need unknown, actually. Put that into the default, but let's see, as is not going to be a starting keyword. So right now I'm just going through and deciding which ones are going to be ones that are like possible starting keywords. Let's see, async and await. I think those should be valid, because you could have theoretically something like async function and then blah 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 blah, whatever the name is. That seems to make sense to me. Bool doesn't make sense to have. Same with break. That doesn't need to be there. Const can be there. Continue doesn't make sense. I don't think defer makes sense either. At like a global scope, right? Right now I'm basically just deciding things that are globally permissible. Same with do. That doesn't belong there. I don't think else makes sense. That doesn't need to be there. Enum needs to be there. Export needs to be there. So type names don't get to go there. I don't think true and false makes sense to have. I guess it's not invalid, strictly speaking, maybe. No, I won't. I don't need that. Loops, that's fine. Function, that's fine. Types go away. If statements, those will be permissible at global scope, I think. Maybe, I don't know. It kind of depends on whether or not I want to make it so that like a file can just be executed as sort of like a script, or if I want to make it more similar to C by having a main function. I think I want to allow it to execute sort of like a script, and in that case there are some possible things that I didn't include there. I'm going to work under the assumption that it's not possible at global scope to do that for now. Might end up changing that. In also goes away. Okay. Back to token.h and start here. All right. Just go through. All right. Macros definitely valid at global scope. Match. Nope. Null, definitely not. Return, nope. True, nope. Type, yes. All of those go away there. Union is fine there. And let's see, if I'm excluding if statements, then I'll also exclude loop stuff. We don't need that there. Okay. Now, yeah, we'll start with that. Okay. And I'll actually get rid of these because none of those are valid at global scope. So let's define the default. So error type. Actually, I should probably go ahead and have the expression. It's just going to store the current global level expression, I think. I think that makes sense. I have heard of it. I don't very well understand some of that stuff. So let's see. Hang on here. Hold on. I know that they are parsing methods. Yeah, look ahead, left to right. Yeah, I've heard of this. I've read some about this stuff, especially when I was looking at Tree Sitter, but I haven't really been concerning myself with the terminology used. So, what's that? Yeah, and I know that, for example, the parsers that are generated by Tree Sitter are, well, first of all, the file size is large enough to make it so that they're not really readable on GitHub without using the oh gosh, what's it called? I mean, it's raw mode, just like the plain text of it. It can't like format and do anything like that to it, and so it doesn't allow you to read it in normal mode. So they're really massive files, and you've got arrays that are filled with all the various states, because it's describing a state machine, and so it's got an array that describes the state and then whatever possible character value you could get, which I may end up doing something like that in the future, but I definitely don't want to have to do that, write that out by hand. So I would much rather have something where I can generate that automatically. Like, you get what I mean there. So anyway, case type. All right, so that's going to be type error. All right, let's start with var. So we'll call so that is the plan at some point. Initially, it's just going to be transpiling the code into C code, and then I'll compile that. But I would like to have a built-in REPL, just if for no other reason than making it so that you don't have to stop what you're doing and compile, because that's one thing that definitely does kind of make things a little more difficult, especially if there are long compile times, which may or may not happen, depending, because I'm not totally sure what all the features that I want to include. But if, for example, there's a lot of evaluation and optimization, then that's something where you kind of have to. So my idea, and this might be naive of me, but my idea is to have it so that it can operate as both at some point. That's not going to happen straight away. I'm working on making it a compiler so that I can write it in itself at some point. But for now, I'm writing it in C, and then once I've gotten it working, I'll write the compiler and the interpreter and some other stuff in its own language, and then it'll be able to compile itself. That's kind of the idea. All right, so let's see. Okay. So then this will go to, and I'm going to go ahead, I'm going to define a, yeah. And you know what, I'm going to do this, let's see, should I do it lowercase or uppercase? Guess it doesn't especially matter. Do uppercase. All right. Would then go to label. There. I'm using that define quite a lot, so might as well just define it now. All right. So this will advance to parse. And go up here real quick. Just get rid of this. Okay. And all right. So just need to start defining some of those labels. So yd parse deck. And then parse error. Okay, I'm just going to say I'll have to deal with what this is actually going to return later, but for now we'll stick with that. Okay, so define the rest of it later. Okay. So we're at var declaration, so it needs to get a let's see, token type. No. So the tokens are actually. Let's see. Can I get that? Okay, let's do that. So the tokenization process happens as the parsing is happening. So basically, the parser is going and it requests the tokenizer, the lexer, to get a new token. It then stores that token and it just stores it right here. And it goes through and it starts looking to see what that ends up meaning to the state of the parser. So no, I'm not storing the tokens. And actually, I don't need to include that. I'll just type out code equals. There. It's not too tedious to write this. It is kind of tedious. I'm going to be doing that a lot. Now we will define it. I don't want to spend that much more time doing that. Continue. There. All right. Okay, and then default, it's going to advance to error. Not Lex. Hold on, that's wrong. Um. So I don't know if I actually need to backtrack. I mean, okay, it's possibly true. I might need to backtrack. I don't know if that's something I'll need to do. If I discover that I need to, then I guess I'll have to do a bit of reworking on this. Um, but in my experience so far, I haven't run into a situation where I've needed to backtrack. So maybe I'll discover that I need to here. If so, I'll have to change my strategy. Okay, so then check. Let's see, the next one. Let's see. So there's a couple of options. Oh, and I should, here at the top, I should have case YDTT arrow functions. I don't know what that refers to. Hold on. What are arrow functions? Okay, let's see what that is. Okay. Okay, so it's syntactic sugar, basically. I don't really feel the need to. Maybe I'll discover that that's more useful to the point where I decide that I need that, but like I don't think it's some great imposition to have people declare their functions with the normal syntax. So, okay, that's going to go to parse end. Okay. So next here, att new line. that is going to advance to yd parse start. Case yd tt. Let's see, the colon, and just go continue. Is there any other possible options? None that I can think of. None that should be valid. So advance yd. Yeah, not really. I don't know. I've used that stuff before because I've done what do you want to call it? There's a game called BitBurner that uses JavaScript as its primary scripting language. I've used it. It's a neat idea. I don't know if that's something that I really need. I don't know. I'll have to think about that some. And it might end up being the case that I allow for something like, oh, oopsies, screw that. Let's see. Oh, jeez. There. Let me think here. Like something array, filter, and then function. Something like this. Right, this could theoretically be a thing. But I don't think that I need any backtracking. And actually, that's... Okay, so why does that need backtracking? As I'm not sure exactly why that's required for that to function. Because you've got the specific operator kind of thing, which is this little equal sign arrow constructor, I guess, construct, whatever. Right, so that's, you see that there. And so that all gets parsed, and you parse that. It's like, oh, okay, that's a function, essentially. And so then you take whatever expressions are in there and you put that into a function. Why wouldn't you know if there's the arrow? I mean, it's right there. Like what I'm kind of thinking is, so let's say that I'm going through this here. So we've got ID, which is the identifier of the X there. Then you have a decision tree where, if it's just X, then I guess, I don't know what necessarily would happen, but, whatever, doesn't really matter here. And then you check, and if it is that little arrow operator, then you would say, okay, that X is actually going to be an argument for a function. I'm not sure I see the need for backtracking there. Like, I think you can just read that left to right and have it be parsable. A comma expression. What's a... Okay, these are things... Let's see. Expression. What is a comma expression? Turns the value of the... Okay. I don't think I'm going to have comma expressions that work the way that that JavaScript does this, because I'll be honest, that seems kind of weird. I don't think that's something I'm going to be including. And like in as far as the idea of passing functions to passing functions to a function. So in the case of filter, like as far as the syntax is concerned, I think I'd prefer to have sort of a lambda syntax that's a little bit more obvious to the reader. So something like, you've got array.filter and then function, whatever arguments, and then typical, like more typical function syntax rather than condensing it to use the arrows, because I'd rather there be a bit more clarity. And so I think this is much more clear. It's immediately obvious, excuse me, what's happening here. Whereas unless you know JavaScript, the arrow syntax is very confusing. Or I guess there are probably other functional languages that use that arrow syntax, but this kind of thing, we'll say true. C also has a common expression. Huh. Wait, is that for, yeah. Okay. So I've never seen that used or even talked about in C. Does C have that? What does that do? Comma separates, no, okay. So binary operator evaluates its first operand and discards the result, then okay. Yeah, see, I've never run into a case where I've been using that except for in for loops. Actually, yeah, I haven't used it in for loops either. I basically just, um, like, I basically never had an instance where I've used it in a for loop. So that's new. I didn't know that. I didn't know that was a thing. But I don't see how I don't see how that's actually a problem either. I might include comma expressions in this language, but I may not. I haven't seen it used in practice, so maybe that's something that's more useful. But I don't see how you could still not just do something like this. You're parsing, everything's fine. Okay, that's a comma expression. Like it's doesn't. I don't see how I'm required to backtrack in order to detect that, basically. Because the state of the parser is going to change to reflect whether or not you're going over a comma or whatever it is you're doing. I don't see how the parser is forced to backtrack there. Oh. All right. If it's anything else, then that's an error. So let's go to parse error. Okay. It's colon, then we move on. Oh. All right. That's where things are a little bit few more options. So we need to include all of the primitive types. Let's see. Just go ahead and include these in the order that they are found, even though I don't think that actually changes anything. Oh shoot, I didn't realize it was going for that long. Huh. It's already almost 11:30. Okay, let me just go ahead and finish this up. This won't take very long. I'm just going to copy. Oh. So replace that with a U. Is there anything else I think of? I guess function should probably also be included, and type. Actually, those would go first. Let's go earlier. Hold on. Right here. So, case function. I think that's right. Or do I have it? Yeah, it's function. Okay. And then assume type is also valid. And finally, ID, because you could have a custom type. Like, you know, yeah. And then the rest are going to be errors. So, I guess advance YD parse error. I might decide that advance isn't really helpful. But all of these are a continue kind of thing. And I might need to end up modifying that. Anyway, that's a separate issue. So, already well over time here, but I kind of got sucked into this. So, I do not have a Discord for this. So, no. Anyway, all right. Well, thank you all very much for watching, and I hope you enjoyed, found it interesting. And I will see you again tomorrow, hopefully. So, have a great day.